Good morning, ladies and gentlemen. Welcome to the IDEA StatiCa webinar. It's the latest issue. It's the latest issue of our Connection Wednesdays series, and today's topic can be summarized with a slightly provocative question: is Excel still more effective? My name is Ondřej Hudec. I'm a product engineer here at IDEA StatiCa. The main presenter today is going to be Alexander Shotkovsky. He's the one who prepared this webinar for you.
Hello.
Just a quick reminder, we are on GoToWebinar platform. All attendees are muted by default, but it doesn't exclude you from the discussion. On the contrary, we would like to encourage you to ask us questions. You can use the questions panel dedicated for this. The whole session will be recorded, and the recording will then be made available to you. It will be also published on our website. As I said, the topic is the comparison of Excel versus IDEA StatiCa connection. Sasha is going to show you how the structural engineer works using just Excel sheets for his design of connections, and what options he has when he uses IDEA StatiCa connections, including some new features in the version 24.1, which has been released recently. After the session, there will be room for your questions and our answers. But right now, we would like to ask you a question on our own. I just opened the poll, and I kindly ask you to place your vote. We would like to know, how often do you use BIM links? Is it in every project, more than in half of the project, less than the half, or even never? We know that there is a big difference in different parts of the world. So we want to know what the situation is with our audience today. Okay, it seems that most of you already voted, so I will wait some 10 more seconds. So please, who hasn't voted, do so. Okay, I'm closing the poll now. I can share the results. As you can see, most of you don't use BIM links or even have never used them. So I believe this webinar will be very useful to you, as you will see what benefits the use of IDEA connection and BIM links can bring you. With that, I will pass the word to Sasha, who will walk you through the whole webinar.
So thank you, Ondřej, and let's go to the webinar itself. So let's compare the Excel versus connections. How generally you handle connections in Excel? Standardly, you select a group of the same connections, you give the names to it, you find the maximum loads of the groups of the connections, and easiest but probably not economical way, you create envelopes for these groups of connections. Then you go directly to the Excel sheet and set the loads to the Excel spreadsheet and design the connections. Something like Greenbooks in United Kingdom, or in DAS in Germany, or something in other countries. But generally, is it so that your Excel spreadsheets can always handle all the 6 forces you have in the connections? Probably yes, probably not. That's the question. And also the next thing, if you have formulas in your Excel spreadsheets, is it always so that you can cover all possibilities you have in these connections? Maybe you have some formulas for 2 boards, for 4 boards, but maybe if you want to use different kind of boards, for example, 6, 7 or so, is it really done in the spreadsheet? That's the question. And the next thing, also, do you have all the warnings regarding the code and other things in the spreadsheets? Probably yes, but in IDEA connections, we can handle it much easier. And also the post-processing from the Excel sheets. You have to create a connection report, and of course, you have to create some output for the checkers and for the detailer. So it's not so easy. And not to forget, if there are some changes in the structure, you have probably to do the same thing once again and duplicate the job you have done before. So now, how we handle it in IDEA StatiCa? Of course, we have to import the same joints and the loads.
Sasha, sorry, I have to interrupt you. I was notified that you don't share your screen.
Oh, that's sorry. So now, okay. So it doesn't matter what I have explained before. It's quite understandable. So maybe I can continue. So we can export the structure to Checkbot, and now we open the important joints, apply our templates with our following advantages. So we have the full control over the design. We have all the forces in the joints. We have the detailing checks also in it. We have even automatic sketches in our application. We can easily create a report. And we have, of course, possible path synchronization through the Checkbot if any changes in the structure appears. And regarding the post-processing, we export, of course, connection report very easily. And for the checkers and for the 3D CAD detailers, we can export either IDEA.con for viewer, or we can even create an IFC file to see the position of the joints and how they look like. And now I will show you how it works in IDEA StatiCa. So let's go out of the presentation and jump directly into the software. So I have prepared a small structure in SIA engineering. It's already computed. So we will jump into the IDEA StatiCa checkbot. And it is here. So you see the whole structure is imported into IDEA StatiCa checkbot with all these joints we have here in the tree. And let's start with, for example, this one, this joint. So I will open it. And it takes some minutes, but it's here already. Okay. And I have two possibilities. The first standard possibility, what we had before the version 24.1, we applied a standard operation to it. So I will show it only as an example how to make it in the standard way. And here I will change it a little bit. So yeah, take 8. Then here I will put 1, 4, 5. Here I will add the boards with the diameter 12. And okay, radius 119. And here number of boards, number 6 of boards. Yeah. So, and then I have to put another operation. This is the rip. And it will be here again, changing the plate. And well, here can we can leave 60. 1, 2, 5, chamfered, triangle, chamfered, dimension 16, 16, 30, and 360. Yeah, you can. It's here, and here we have to change it to the plate. Yeah. So here this one, and here number 6. So 6 ribs on the one side, and then another side we will copy it and we will put it on the other side with the plate. So this is the standard possibility what we had before version 24.1. Yeah, and it takes some minutes. For example, I measured it, and it took me about 1 to 2 minutes to create these 3 operations. Now I will delete it, and I will show you the other possibility which we are prepared for using for standard connections. And now a new window opens, and what's important, we have right now here a tab with a possibility to check in the parametric design. And in this case, we have some standard connections which can be used with this parametric design, with this one. And I will only change the diameter of the boards. And the whole joint was created, was designed by one click. And now, of course, for these operations, we have some possibilities. You can see here in the tab on the right side, we can change the thickness of the plates. For example, we had before the 8 millimeters, and number of the boards, we had not 8, but 6 numbers. The stiffener depth, it was 125, what I already added before, and the rest is the same as before. What's the difference between the operations I had done before and these 3 operations we have right now here? The difference is that you are not able to access this operation in the right tab. So is grayed out. So all you can do is apply these parts of the tabs. So these are the items you can change. Yeah. So these are not possible. If there's a need to change something else, for example, the welds can be accessed in the 3D, in this 3D window. So here you can change, for example, the welds. Yeah, so can be changed to 5 millimeter, for example, but nothing else. So if you would like to have, for example, the diameter a little bit different or something else, you have to do something else. And that is the operation here, or the button explode. So if you want to change something else that we had before, you have to click on explode. In that case, we have done it. And now you see these three operations are accessible and you can change everything you want. Yeah? So this is the one example what I wanted to show it to you. Now I can save it. Eventually I can make the computation, but it's not necessary. Maybe I will do it. For the calculation, if in case you have a lot of load effects and maybe this in the tree, you have 20, 30 load cases, there's also a possibility what we had added before is the calculate load extremes. In that case, you can see only these 4 load cases are important for this joint. So I will calculate it, and in the between time, I will show you how this calculation is prepared. It is so that we have here on our web pages, we have here a knowledge base article. It's called Load Extreme section. And here, according these formulas, we are computing the extreme loads, which are significant for the each joints you are calculating. So you can use this button, what I showed it before, to select only the important load cases and make the calculation. So, okay, it's done. I click on save and close it. So let's go to another joint. For example, I will select this one. This is the footing. Open. So it's here. And again, I will try to apply our parametric template. So I will click on parametric. Oh, sorry. I took not the correct one because we have other. Not for every joint we have. It's not right now. All the parametric design is not prepared, but I will talk about it a little bit later then. So I will do this simple column and click on propose. And again, click on parametric, and you can see we have more than one here. And I will select, for example, this one. Okay. And well, we can leave it as it is. Yeah, so you can see here are much more operations needed to create this footing. So it's really easier to prepare something like that. And here, for example, I can click on widen or web. That means that it will disappear and we can compute the joint as it is right now. In case, as I spoke before, we want to change something, I will explode it again. And for example, we have here these washers with the thickness of 20 millimeters. Next, very useful feature what we have right now. You can select using the control button and mouse. You can select all the washers. It means this one, this one, this one, and the other one. And here I can, at one click, change the thickness of these plates from 20 to 16 millimeters, for example. Yeah, so this is the possibility what you can do. So we can again make the calculation. I will click here on the load effects. Okay, excuse me. Calculate all extremes, and you can see instead of 20 to 20, 15, 20 load cases, we have only 3, which are significant for this joint. So, and what we would like to show to you, what's behind the parametric design, where you can create your own standard connections. We have about 50 parametric standard connections in our software, but you can create also your own. And how to do so? Maybe I will save it. And how to do so? Close it, and let's go to the here to this application, and if you click on the preferences, you can click on the developer mode and enable the developer tab in the ribbon. Save. So let's go again to our checkbot, and we will maybe try to show it to you how it works if we have the parametric developer mode enabled. So we will open this joint, for example. So here, and we will apply again one of the standard connections with parametric design. This is this one. I can change it, for example, here. And you can see we have here a thin plate. Maybe what we can do is to change the offset to 150 millimeters. Yeah, you can see everything happened. And now what the difference to the standard appearance of the connections. We have here the developer tab. And in the developer tab right now, you can see the parameters which are responsible for these operations we have here in the 3D model. So it means that now, right now we have here parameter thickness 10 millimeters. I can change it. I can make, for example, 12 millimeters and click on Set to Model. Then if I go here, you maybe noticed it changed the thickness to 12 millimeters. And if I go back to design, here you can see the number change from 10 to 12. So this is the way how you can create your own standard connections according to the rules you have in your company and so on. And for this, we have again small hints for you, and you can find it on our web pages. If you go to tutorials, products, field, and here IDEA Open Model API, you can see here 2 tutorials. The first one is parametric design in IDEA StatiCa connection basics, and the second one is the same with advanced. And here you can learn all about these functionalities, how to create your own standard connections using the parameters in IDEA StatiCa. So let's go back to our example. We can again make the computation, calculate all, and click calculate. So everything is okay. We can again click on save and close it. So, and now I will show it another features we have added to our application. Right now I will click on with the right click mouse on none and click here sort by status. And now you can see at the first rows are the joints we have designed and calculated. Yes, these three are done by me in the time. And now we have again possibility with clicking control, select all three joints, click with the right mouse button and click on export. And I will click on connection. I will maybe here put test. Doesn't matter what the name I select. And the same I will do for IFC. And make the same name test. So save. And now what we can do with these files. First, I can click on viewer and we'll select these multiply file with connections. And you can see here we have all three joints in one file, and you can send it to your detailer to look at it. It's even with the load effect. So you can, if you click on it, you can see here the load effects we have used for the computation of the joint. So this is the one possibility what you can do with this file. And the second one, we have also the I have to look at it. Cannot find it. Sorry for the delay. I do not have it here. Maybe just a moment, please. Excuse me for the delay. I have put it on the other. Just a moment. So, and now we will look at the file with IFC. And now you can see here we have all three joints we have created, and they are even correctly positioned in the 3D. So you can see here our 3 joints we have here. Yeah, so it depends how we want to look at them. So, and this is the thing what I wanted to show to you today, and I will pass back my word to Andrzej.
Okay, thank you, Sasha, for the presentation. So now it would be the time for your questions. We had quite many about the screen not being shared, so I believe we successfully answered these. There was one additional question during the webinar. Is the export from another program than SIA, e.g. AxisVM, or even from a CAT also possible? The question is yes. You can find the list of supported integrations on our website. As you can see, every major FEA software is supported, StatPro, ETABS, and so on. And you can even use BIM links with CAD software. Again, there is a list. And you will not only find the list of supported integrations on our web page, there are also tutorials for each of them that will teach you how to activate the BIM link and how to use it effectively. That's deep. Right now, there's another question. How can I export connection from IDEA StatiCa to Tekla structures as component? Would you like to answer this question?
Yes, I will answer. It is so that right now the link between all the software we have in our list, and even with Tekla, is one-way link. It means it goes from Tekla to our software. There is, I would say, a small possibility how to do it in the other way, but the important thing is that it's right now possible only if you are using Grasshopper as a parametric software. There's also a nice LinkedIn post where you can see it how it works. It's for our company. We are trying to do it also in the other way, but right now it's only in preparation, and we hope it will someday happen that it will works. But right now there's only one way link to it. But in the future we do not, we can imagine that it will work also.
Okay, Sasha, and then there's another question. There is no compatibility with Allplan CAD from Němeček. Is this BIM link in planning?
Yes, there are some thoughts about the BIM links to Allplan, but it's still in preparation, and I'm not able to tell you where it can happen. Can be that it will be very soon, but there are some other problems because it is not only about steel but also about concrete. So we are still working on the possibilities how to do it, but right now it's not. If there will be a link, we will of course inform you in advance.
Okay, Attila Sabo asks, why is it not possible to slightly move element of the connection in the connection module? I mean when I use Checkbot. For example, column-based bracing member, and I need to move the bracing member a bit upper to sweep.
Yes, it is so that the Checkbot is our main HubSpot for interacting between our applications and the original structure computation. And the Checkbot is we do not want to lose the correct loads from the fair software, and to maintain the original equilibrium in the joints. So it means the only way how to disassemble the joint, but to lose the original load effects is to store the joint somewhere else and lose the connection to the original fair software, or what you can do is to move the eccentricities. You can add some eccentricities to the members, but it's very limited because we do not want to lose the equilibrium in the loads from the original fair software. That's why it is so limited. If you want to lose the connections to the original load effects, you can of course store your joint somewhere else and to design it according to your needs, but you are losing the link to the original fair software. That's the issue what we have in the Checkbot.
Okay. Will a link be available from master series to IDEA StatiCa in the future?
Excuse me once more.
A link from master series to IDEA StatiCa. Will it be available in the future? You know about this?
I do not know. Sorry, I cannot answer that question right now. Maybe later, but right now I don't know.
Neither. And there's a reply to your previous answer. Yes. I believe it's just a comment. That's not really a question. It seems we have run out of questions. So would you like to add something, Sasha? Or was it all from your side?
Maybe what I didn't tell very extensively, but this webinar is only a first part of the workflow, what we are preparing for you using the standard connections. We would like in the future to make it as easier as possible for you. So you can expect much more features regarding these standard connections and the workflow in connections and BIM links in the future. So maybe in the version 25, 25.1, there will be much more features in these directions, and we are very optimistic in these things that we will be able really to make the job for you very, very, very fast and very easily. That's what I wanted to express.
Okay, thank you, Sasha. And with the Q&A session over, I would like to invite you to our next webinar, which is happening on the 4th of December, with the topic being anchoring with reinforcement. We will show you how to export the steel to concrete connection from the connection application, and how to code check the anchors with the reinforcement taken into account. So we will be looking forward to seeing you there again. I would just like to remind you that we have the support center. You can see the link on the page. You can find there many more additional materials. If you have any questions, you will find there tutorials, recorded webinars, theoretical background, and so on. So please feel free to visit. And what you will find it there is also our campus. That's educational course online that you can complete. It will teach you how to use the IDEA StatiCa applications effectively, and you can even get a certificate upon completing a short quiz at the end. So thank you all for attending and for your participation, and we will be looking forward to seeing you at our next webinar. Goodbye.
Bye.